Hello everyone. Hope you are enjoying the training program and making the best out of it. And very good day to you all. Myself, Dr. Anirban Middey, Senior Scientist, CSIR-NEERI, Air Pollution Control Division. Today I shall discuss on the topic Meteorology and Air Quality Response System as Integrated City Services, Approaches and Challenges for City-Specific Action Plan. I have distributed my topic in the following contents. First, we'll learn about meteorology and air quality, where we'll learn some basic meteorology, fundamental of atmospheric processes, effect of meteorology on regional air quality. Second, we'll learn how to visualize and interpret the data, meteorological stations, instrument, and data analysis. Third, the role of meteorology on air quality forecast model, types and choices of model, some hotspot identification, what are the constraints for this kind of integrated models, etc. Fourth, what are the challenges for city-specific action plan? How these local feedback mechanism are playing key role in meteorology air quality couple system. We'll see about that. And the last one, way forward, and very good way to tell that proactive planning is very good than that of reactive response. The first chapter is meteorology and air quality. Now, what is meteorology? So it comes from two Greek words, meteors and logos, which means the study of things those are aloft. The tendency of any fluid is actually from going towards the low pressure region from high pressure region. Take it any compressible fluid. So air is a fluid, we consider is a compressible fluid. Now see the first chamber where air particle is 3 number of air particle is there, and the second chamber where also the particular 3 in number, but the pressure is different. Okay, if we somehow connect these two, what will happen? This compressed chamber will get released somewhat and there will be some equilibrium. Okay, so actually the air from this first chamber will go towards this second chamber and there will be some equilibrium in the system. Similarly, in the atmosphere, air always try to move from high pressure region to low pressure region. This is the natural trend. If we see our atmospheric stratification, we can see that the sea level pressure is the highest. Then if we move along the altitudes, we are getting lower pressure region. So generally there is a tendency to move air from surface to upward. That's why everything is try to go aloft. That is the term meteorology. Now what is pulling them down? That is called the gravitational pull. Okay. So that are in balance, and how that is overcome and various meteorological processes, we will see that. Now in classical meteorology, we consider air as a parcel. It is called parcel theory. A parcel of air is defined using various state variables. There are majorly 3 state variables: density, pressure, and temperature. We can define any air parcel by these 3 state variables. And if 2 air parcels are different, then obviously some of the state variable between them are different. So these are various atmospheric processes. An air parcel follows several different paths when it moves from one point to another point in the atmosphere. So these are called like isobaric change, okay, where pressure are constant, then isothermal change, isentropic change, etc., and adiabatic processes where there is no heat exchange. There are some fundamental laws of physics which governs the atmospheric processes, such as conservation of mass, first law of thermodynamics, Newton's law. So apart from this, there are other equations like conservations of water vapor, chemical species, etc. When all these equations are placed in a model, then we can define atmospheric slice and its processes. When we consider all the laws of physics and atmospheric sciences, The atmospheric circulation just look like this. We call it global atmospheric circulation. So there are thermal circulations, there are polar cells, there are Hadley cells, etc. So these cells really affect our regional environment and regional circulation system also. Now, the meteorological factors that are influencing the fate of air pollutant, first we call wind speed and wind direction. We call it a carrier. It carries the pollutant from source to receptor, and it has a great role in dilution and dispersion of the pollutant in our atmosphere. Second is temperature. It is a state variable of atmosphere. Measuring temperature supports the air quality assessment and air quality modeling and forecasting activities. So it is very important parameter. Second is relative humidity. We call it reaction maker. So water vapor plays a very important role in many thermal and photochemical reactions in the atmosphere. Fourth one is rainfall. We call it the scavenger. Rain has actually the scavenging effect when it washes out all the particulate matter and gaseous pollutant from the atmosphere and cleans it out. The last one is solar radiation. We call it the producer. The intensity of sunlight has an important influence on the rate of the chemical reaction that produce the smog. Let's just go through the concept of static stability. Just look at in these three figures, where the first one is the rolling marble. We can call it the rolling marble theory of stability. In first case, the marble is in equilibrium, because if we displace it from its original position, it will try to regain its equilibrium position. So it is in equilibrium. The second, the flat surface, it is called neutral. If we apply some force on this marble, it will move along the force line and suddenly it will stop due to friction. The last one, it is unstable. If you move this top marble from its position, it will never come back to its original position, or neither it will gain any stability. So when we apply force to it, it will try to act like this, and it will try to regain its original position in this moving bowl. Now in atmosphere, the same thing is happening. Suppose a air parcel is at a particular height, suppose 100-meter or 200-meter height. Now you just force it to move upward by virtue of giving some heat or some energy, external energy. So what will happen? It will try to regain its original position if the atmosphere is in stably stratified conditions, and it will try to oscillate. So this kind of oscillation is continuously happening in our atmosphere. So it is called Brandt-Weissel oscillation, and it actually defines the fate of your atmospheric pollutants, the mixing of your atmospheric pollutant in your regional atmosphere. So the stability classification in the atmosphere has very vast and historic background. Generally, Pascal-Griffith method, PG method, or the stability array method, or some other methods, wind speed ratio method. These are all the methods or schemes that are used for classify your atmosphere according to the stability. Okay, and these things are also used in numerical modelings or air quality forecast models. Let's just check out some of them. The Pascal-Griffith stability index actually considers your daytime insolation, nighttime cloud cover, and surface wind speed. If these are in this kind of range, we call it stable classification of A, B, C, or D. Okay, so A means extremely unstable, B means moderately unstable, then slightly unstable, and etc. Okay, and also we consider cloud cover here, the daytime insolation and nighttime cloud cover. The sigma theta stability classes actually same as Pascal classes, but rather than those fuzzy A, B, and C kind of thing, they uses some numeric values like sigma theta value greater than equal to 22.5, then we call it extreme unstable, moderate stables, slightly unstable, neutral, etc. Wind is a very important parameter, as I told in my earlier slide. that it is actually termed as the carrier. It carries the pollutants from source to receptor. And to represent wind in a proper fashion, we need some tools where we call famously it is called windrose diagram. Now, representation of its windrose is very important for any chosen site. Okay. Now, what it represents? It represents some frequency circle or percentage of reading and wind speed category and the resultant vector of average wind direction and also the percentage of calm wind. Now we should remember that adding all these percentage of all the winds, including the calm condition, should equal to 100%. Okay. Suppose you have 100 observations, it is placed in this windrose diagram. So when you consider this northeast direction or northwest direction, all these wind petals, the rose petals, should come up with a equal to 100%. Otherwise, it is wrong. Now, fair judgment for establishing air quality station, we need proper justification, upwind, downwind direction, etc. But the irony is wind is always changing because the pressure field is changing. Okay, so wind is nothing like the reaction due to the pressure field change. Okay. When there are high pressure and low pressure system, so according to that pressure field, wind will flow from high pressure region to low pressure region. Sometimes the gradient is so strong that you will get the strong wind, or there are calm winds you can get for some lower amount of pressure difference. Okay. So it is continuously changing because there are seasonal reversal of wind, there are seasonal changes in the pressure field. So sometime it is coming from southwest direction in the summer season and sometime in the northeast direction in the winter season, especially in Indian conditions. Now, how you will just decide about the air quality stations in your study location, in your urban city specific locations. So if you just consider your center point like this in this yellow flag, so there are some emission sources. Suppose your city center is here and there are some huge amount of emissions is there due to roads or some vendors, etc. Now you place your positions in upwind and downwind conditions, but you omit the crosswind sections. But believe me, throughout the year, there are major winds, if you consider those percentage, are in the crosswind directions also. So if you just misplaced one those or miss one those crosswind direction, you will not get representative sampling or representative data for your study locations. So it is the slide showing the monthly changes in the windrows, the rose petals, that it is something from the northerly direction during the winter and gradually towards the south and southwest direction during the monsoon periods. Okay. So the monthly variation of wind speed and direction as displayed in the windrows for station, it is displayed like this. And good understanding of prevailing wind is must for dispersion modeling that leads to GLC detection, that means ground level concentration detections. Let's move towards the chapter 2, that is visualization and interpretation of the data. If we go to any meteorological stations and ask them to display us the meteorological condition in a chart form, they will send us something like this. There are full of symbols, some designs, etc. For a layman, it is very difficult to understand, but if you are going to study your locations in terms of meteorology and air quality forecast kind of thing, so you should have a very good knowledge about these symbols and the parameters. Okay. So generally, reference method, reference meteorological station looks like this. The WMO technical document is there for placing your meteorological equipment in a stations, and the instrument are also standard. The thermohygrometer for temperature, humidity, standard automatic rain gauge for precipitation, cup anemometer for wind speed, wind vane for wind direction, sunshine recorder for solar radiation hour, then pyranometer for solar radiation and barometer for barometric pressure. Apart from those meteorological station, nowadays we are having automatic weather stations. We can remotely access all the data, and to add that we have satellite observations also. So satellite provides observation of the state of the atmosphere and ocean surfaces for the preparation of weather analysis, forecast, advisories and warnings for climate monitoring and environmental activities. Okay. So there are two kinds of satellite. First is called the geostationary satellite. Now I have shown here. It is stationary with respect to a particular segment of Earth over the space. Okay, so it takes the images at a particular Earth disk only. Then there are polar orbiting or sun synchronous satellite. It moves according to the local time over your head. If suppose if it is moving over your head at 12 noon, then next day again 12 noon it will be at your overhead. So it is low orbiting satellite, almost 700 to 900 kilometer above the surface. It is called polar orbiting satellite. So both the satellite has their own advantages and disadvantages. So we consider a geostationary satellite image. It looks like this. This is our INSAT 3D satellite in the left corner, and the wind pattern is showing that the global, according to the global atmospheric circulation, these are the wind patterns over our regional locations. So seasonal variation of primary parameter are very important. Close watch and documentation is needed. If your region of concern is having some anomaly in terms of these parametric changes, that should be well documented. Okay. So what are those? Wind speed and wind direction, stability conditions, humidity and temperature. So apart from that, there are other parameters like precipitation, mixing height and solar radiation. So these are the atmospheric conditions that influence the fate of your air pollutant. So in-depth study is required to understand what should be the fate of the pollution which is emitted in your atmosphere and how it will move in the atmosphere. Next, chapter 3, the role of meteorology in air quality forecast model. So what is model? It is nothing but the mathematical representation of any physical phenomena. Okay, so we put some lots of equations over a set of time period, and then we try to solve it. Okay. Before going into the modeling part, let's just understand about the boundary layer. Okay, and that too also the urban boundary layer. Now, urban boundary layer is nothing but the part of planetary boundary layer that resides over your urban settlement. It is heterogeneous due to dissimilar surface roughness because your urban cluster has building, trees, and some water bodies, etc. Then again, heavy pollution period can prolong the inversion layer because different surface feedback is there in your urban settlement, and different spatio-temporal scale interaction is there. There are mesoscale interaction from your transboundary transport from other states or other country. Then there are local scale interactions. So your building has different feedback, your grassland has different feedback. So there are different air circulations all over your city area. And there are micro scales. So there are tall buildings, small buildings. So in between them, there are small circulations are there. So all these things need to be considered before going into the modeling part. Now, the effect of meteorology on air emission, if there are strong low-level inversion, so all your emissions will be trapped inside that mixing depth. So subsidence inversion in the diurnal heating that does not break or weaken significantly. Weak surface wind, if you are having very low surface wind or calm condition, then also your dispersion phenomena will be hampered. Okay. And sunny weather, there will be some photochemical reaction possibilities are there. So all these are affecting your air emissions because once emitted from the source, the fate is entirely depends on the meteorological factor only. No one can do anything. Another very important factor is land use, land cover effect. Airflow modification due to surface roughness is observed because if you are having different kind of surface roughness like some elevated land, some green area, then some concrete zone, so there will be different surface feedback. And also there will be changes in surface albedo because the reflectance, sun ray reflectance from each different surface is different, and spatial distribution of stationary and mobile sources and the receptors. Suppose in your city area you are having your industrial cluster in a corner zone of your city. Now it is moved to a different zone. So there will be special distribution changes in your locality, in your city area, and that will impact your emission profile and also in your land use land cover scenario. And changes in local weather, obviously it will affect your air quality in the city zone. Now let's see how terrain feature are affecting your emissions. Say in the left side, we are having a terrain of elevated terrain, but it is below the stack height. And in the right side corner, we are having a terrain height of more than that of the stack height. In these both cases, there will be different scenario. You will get different kind of ground level concentration in each area. Now, that is what we called the structural downwash or building downwash in simpler way. If you are having some construction nearby the emission sources, so there will be forming of some cavity and the airflow, entire airflow is modified. So there are structural influence zone is there. So if you are going to put some air quality stations in your city area, you should consider the effect of building downwash and structural influence zone because it will impact your ground level concentration of air pollutants. There are different levels of air quality forecast model, starting from some very basic screening tool like Screen 3, Air Screen, etc. These are simple estimation of air quality. Then there is some refined model like AirMod, Astal 2000. These are steady state plume dispersion model based on Gaussian plume model. Then some advanced model like CalPUF, SkiPUF. These are used as a non-steady state puff dispersion model. And then further advancement in the modeling is like chemical transport model like CMAC, WRF Chem, etc. These are sophisticated three-dimensional Eulerian grid chemical transport model. And then above all, there are coupled model like WRF CMAC coupled model. These coupled model actually use the exchange processes between the air quality, meteorology, hydrology, and other atmospheric processes. These are very complex model and cannot be run in your laptop or desktop. It needs some server kind of thing. Now, basic and advanced model, there are some like air mod modeling system. It is based on Gaussian plume model. It is a steady state approximation is considered here. So whenever modeling is done, the meteorological factor are very much inclusive in any model, like upper air conditions, like your surface meteorological conditions. So in air mod, there is a particular segment called air met. Only meteorological processing units are there. But there are some disadvantage of this model also because it is a steady state approximation. It uses only single wind field and it is there is no support for calm wind condition or your coastal effect. You cannot consider it. So for a smaller region within 50 kilometer of radius, it is very useful. And also it does not consider any chemical reaction because it is a dispersion model, not chemical transport model. Now further advance is like a puff model like CalPUF. It uses puff kind of model. It is not steady state model, non-steady state model. And the advantages is it can take a long range transport up to more than 200 kilometers. Okay. So each grid point, it consider its different meteorological state variables. It does not consider a single meteorological field, multi-meteorological field and multiple surface feedback it considered. So it is pretty good advanced model than that of simple air mod forecast. And it also considered the coastal effect, that land bridge, sea bridge effect, and considered the calm wind conditions also. Then chapter 4, the challenges for city specific action plan. So every urban settlement is unique. So there is no denying in that in terms of surface roughness, mixing height characteristic, ventilation coefficient, and assimilative potential. Now, what are those things? I already explained the surface roughness kind of thing. That is because of land use, land cover changes and your urban settlement changes. The surface roughness of your urban area changes. And every city has their own signature surface roughness. So the surface feedback is different. And so that the mixing height in that city area is also different. So it is the height to which the lower atmosphere will undergo the mechanical or turbulent mixing, producing a nearly homogeneous air mass. This is very important for dispersion point of view. So if a city is having a maximum mixing depth of suppose 3 kilometer or 4 kilometer, and some cities having a maximum mixing depth of less than 1 kilometer, so there will be different air quality because the maximum mixing depth is different, the dilution process is different. So you cannot compare the same air quality feedback mechanism to each and every city. Consider the maximum mixing height, then you go for that kind of air quality assessment. Then there are ventilation coefficient. Suppose you are having some X tons or X gigatons of emissions in your area, in your city area per month or per year. Then how it will get dispersed in the atmosphere? Okay, so that is defined by the ventilation coefficient. It is nothing but the product of maximum mixing depth and the average wind speed in your region. So it has got a seasonal variability. Not only that, it is having a diurnal variability also, because during daytime the solar radiation is maximum, your thermal ADs in the atmosphere is greater, you are having greater maximum mixing depth, so your ventilation coefficient is higher in the daytime. I have shown in this right hand side figure that in the morning from 0 hour to if you are moving at the 12 noon, then the ventilation coefficient is increasing, then again it is decreasing at the night, evening and night time, and again increasing. So this pattern follows in each and every cities, but the magnitude of this or extent of this ventilation coefficient is typically different in different cities, and that is very obvious. So step two, our goal would be like this. First, we need to understand the prevailing climate of our city region. Then the emission sources, very important. What are the emission sources, predominant emission sources? We need to have a very good inventory of that. Third, the meteorological conditions. What are the prevailing meteorological condition and what would be the annual scenario? Then we'll go for air quality assessment. You put some sampler if you are getting that air quality sample and analyze it, etc. Then fifth is you do some forecasting, the ground level concentration, and then decision making. Now chapter 5, way forward. Proactive planning is better than reactive response. Let us see. Now all these components are in place. Metrology coupled AQ response system. For that we need a study area with full knowledge of LULC, that is land use, land cover and climate. Then meteorological conditions. Then what are the criteria pollutants we need to assess for this particular area. Whether we need to assess all those 12 criteria pollutants or the significant criteria pollutants. What are the predominant sources through the emission inventory, then using of standard samplers, then we'll go for dispersion receptor or chemical transport model. So all this integration will lead us to a metrology coupled AQ response system. No doubt, metrology is an integral part of air quality management system. From US EPA archive, there are process cycle of air quality management. So for every circle, it has some scientific research, like starting from establishing goal, then determining the emission reduction, development of control strategies, implementation program, and undertaking ongoing evaluation. So all these things coming together in a scientific manner, then we'll have some process moduled with air quality management system in your locality or in your area. Global Air Quality Forecasting and Information System GFIS by World Meteorological Organization WMO are already in place. Okay, you can download this thing from their website. What they did, they take a global atmospheric modeling using all the emissions, global emissions and global atmospheric processes. Then downscale it to a regional scale, then further downscaling to the local scale. Similarly, dust and storm warning advisory and assessment system is in place. So you can see it is online system. You can take it from their website like WMO, SDS, WAS, and the prevailing dust load from this westerly direction over our Indian subcontinent is very vivid. Requirements for proactive planning, city-specific meteorology and air quality response system. First thing, we need to understand the city-specific assimilative potential considering the local meteorology. Now every city has its own assimilative potential. So how much it can assimilate, that need to be understood. Second step is city-specific emission load estimation. So this is already in place. Every state pollution control board has their own emission load data, and it can be integrated in the system. Third step is integration of changes in land use land cover process. Okay, and this is very important because every city has its own land use land cover, and that is changing day by day. And final step is regional and global entrainment. In various cities, there is no such information about what are the regional impacts and global impacts over that city. That need to be integrated in the system. I think I have covered the required thing in this topic, and if any questions are there, you can ask or you can contact me anytime through my email. And best of luck for your next lecture and your future endeavors. Thank you.